Hi folks, hopefully you come on back. I'm just putting up a note here on the D2L site. Make sure to hope folks check in and see. Oops, Dr. J. I'm not Dr. J. All right, there we go. So I'll just wait a couple of minutes here to get to that question. My apologies for the hiccup. Hopefully folks will come back. I had to reset my internet and all that sort of stuff. Hopefully things are looking a little bit better now. Let's see. So I'll just wait a little bit for about a couple of minutes here to discuss things. But Abby's question was a good one. I was working on that, but I don't know how much of it folks saw. So I'm just going to sort of restart with where I was at the beginning of answering her question. So, and hopefully folks will pop in as things get a little bit better here. But things look okay from my point of view here. It says we've got a good connection and that my streaming software is running properly. So let me talk about Abby's question, and then I will see if folks come back. Either way, if they're not getting it live, at least you'll be able to see it. So there'll be two broken up streams here today. Hopefully it works okay, and folks won't be too put out by it. But here's the idea. The idea is Abby was asking, how do you get that angle? And I'm going to be, let's say that I've got a force F and I want to calculate how much work is done by force F. Well, you multiply the magnitude of the force times however far the object moved times the angle, and I like to use theta for the angle. She used X in her question, but I'm going to use the angle, the Greek letter theta, to represent that. If you are making it back in, just give a little hello in the chat or something like that, so that I can see that folks are sort of popping back into the stream to get some help and stuff today. So this is the expression. This is the formula for calculating the work, and Abby was asking, well, how do you figure out what this theta is? Well, I'm going to look at a specific situation. Hey, good to see you guys. Avery and Michael are back. Good to see you. So let's say that I got an object, a box or something like that, and this box has a number of forces acting on it. One of them is you're pushing it to the right with a force. We're going to label it P, and then let's say that the ground is pushing up on it as well, this is just like supporting the weight. I'm not going to include the weight because it's kind of redundant, but let's say that in addition to the weight, which I'm not going to draw, there's the normal force of the floor supporting it, and then let's say there's a frictional force to the left, so I'm going to use little f to indicate that, and let's say that this crate is moving to the right so that at some later time its position is over here further to the right of where it was before. So it has moved, and I'll use sort of dashed line here, it's moved a distance d to the right. Okay, so what you do to figure out what this angle is you got to use each of the individual forces to figure this out. Theta is the angle between the direction of d, the direction of the motion, and the direction of the force. So to figure out what theta is, I first draw d. So here I'm drawing d again. So there's where d points, the direction of motion. So remember, d is only the magnitude. I never put signs in for f or for d. I always just put the absolute value, just the number. Okay, and so this is the way that d is. And then I say, well, if I want to know the work that was done by P, I would draw, starting at the same origin there, I would draw P. So I'm going to draw it over the top here. Okay, so there's P. And you'll see here, the angle between D and P is 0 degrees. So that's what I would put in there. For the work done by P, I would have to put in, this is, theta is the angle between F and D. This would be, for this one, it would be the cosine of 0 degrees, which is 1. Okay, but what if I wanted to know how much work was done by N? Well, you'd have to put whatever the normal force strength is times whatever D was times the cosine of the angle between N and D. Well, for N, it looks a little different, doesn't it? D is still directly to the right. There's D. And then N is a force that points directly up. And you'll notice that this angle, so this is N, this angle is a perfect 90-degree angle because one is to the right and one is straight up. So this would be the cosine of 90 degrees. And if you check that on your calculator or remember it, that's 0. So that means the work done by the normal force, no matter how big the normal force is, no matter what the distance is, the work done would be 0. Now, I'm going to clear this out so we can sort of see what the next thing is. And that will be the work done by the frictional force and the angle that's associated with that. So for the frictional force, I would again draw D. So there's D. And then I draw the frictional force. So remember, here's your vertex. Then I draw the frictional force. And I see that's to the left. So it's a small f. So there it is. And then you'll see the angle we're talking about here. This is a 180-degree angle. They're exactly opposite one another. And the cosine of 180 degrees for an angle is -1. And that's why friction does negative work. The sine of the work, or if it's 0, that also gives you like no sign. The sine of the work is always determined by the cosine because you're always using the magnitude of the force and the magnitude of the displacement of the object, the magnitude, how far the object moved. These are never by themselves positives or negative numbers. They're an unsigned number. You always take the absolute value. That's what F and D are. They're always absolute values. The sine of the work is always determined by the cosine function, either positive or negative, or in the case of the angle being 90 degrees, it would be 0. Okay? Hopefully that answers Abby's question. I don't know if Abby was able to come back. We have a decent number of folks watching, it looks like. So hopefully that answers her question. If Abby is here, could you give a little wave and say that worked out or not? Or is there anyone else that thought it was confusing that clarifies it? And again, other questions, just pop the questions. Don't wait for me to pause. Just put the questions right in the chat and we'll get them dealt with. All right, good. I'm glad Abby made it back. Glad to see Abby. Good. I'm glad that was helpful. So that's how you figure out the angles for that. And that's how you can get, you see how the work done by the push here, that ends up being positive because it's cosine of 0 degrees, which is +1. The work done by friction is negative. So they partially cancel. The work done by friction, is negative. So, positive plus a negative gives you get a smaller number than you had before. It's also possible maybe if the object is already moving to the right, but the frictional force is bigger because you got tired of pushing so hard, so you push less hard as friction pulls, then the overall work might be negative and the object's slow. All right, so we had a bit of a hiccup there in the net. Hopefully it's restored itself. Let's see if I can. I'm going to check the chat. I'm going to do a check here. All right, so it says mine shows the chat back. Again, apologies for the internet hiccups here. I just checked and it's not just local to my house. I thought at first that it was just local to my house, but it's a little bit more of a global thing in the neighborhood. So apparently folks are busy on the internet today trying to work from home, I guess. My apologies for that hiccup. So I know we lost a couple of viewers here. Hopefully they just pop back in and we'll see. Are there any questions here? Well, we got reasonably good connection. Sorry it's a little bit intermittent today, but we're doing all we can here to try to make this work as well as we possibly can. So are there any other questions that I can answer? So while I'm waiting for questions to pop up in the chat, I know that there are a couple of other things that are probably happening right now in addition to, about decisions and stuff like that. I think you received an email last week, or maybe late the week before last week, that talked about the possibility of you switching over to a pass-fail grading system rather than taking a letter grade. Let me address that a little bit, and I'll put out an announcement on this as well. But I do want to address that a little bit here. There are only a few circumstances under which I think you should consider going to pass-fail grading instead of taking a standard letter grade. And the reason the college is offering this is because you didn't sign up for online instruction. You signed up for a face-to-face class. And if you think that your performance is suffering because of that, then you should have the option to change your grading format to pass-fail instead of taking a A, B, C, D, or F. And I think that's fair, but for most folks that won't be something that you should really concern yourself with. There are basically a couple of circumstances under which you might consider this. Okay, the first is if you don't need this class to do anything for you. So like if you're a high school student taking this PSEO, you only need to pass the class to graduate probably. And they're going to be understanding about that. So that's one situation where you might choose pass-fail. I wouldn't recommend it because most folks in here are doing well enough that I would say that they might as well take their letter grade. There aren't going to be very many people that are getting a D or something like that, D's or F's in here, unless you're not participating at all, in which case then you should just withdraw. But if you're participating and things are going reasonably well, then I would just say take your letter grade, no problem. The other circumstance the only other circumstance that you might consider taking pass-fail instead of taking the standard letter grade for the course is if you're looking at a situation where you're really worried about your GPA. Pass-fail, the only real advantage is that pass-fail does not count, neither helps nor harms your GPA. It doesn't affect your GPA at all if you take a pass-fail. So if your GPA, and in order to get a passing grade, you need to basically get above the threshold for getting a C in here. So the only real concern you should have is if you're getting a C and your GPA is, in that range where it would hurt you or something like that. But I wouldn't worry about that so much at this stage. Most folks are going to get A through C anyway, so you're mostly passing it. So really the only way that you're helping yourself is if your GPA is really high and you think you might get something lower in here, which I don't think is going to help you. They've said that for folks that need this class to count for something, like the folks that are doing rad tech or something like that, they've already said they're going to accept a passing grade as just okay, but they're going to have to probably alter their requirements a little bit because they used whether you got an A, a B, or a C to determine whether you got in or not. So there's some problems with that. So I would say just take your letter grade and just go. Don't worry about pass-fail. I would say almost no one in this class should be worrying about changing over to pass-fail. I would, if you have a concern like you might want to switch over to pass-fail grading, then ask me about it. Send me an email or something like that, and I'll look at it and we'll talk together and we'll decide together whether that's useful for you. You also, before you make that decision, talk to your counselor or your advisor in student services to make sure that it's a good choice for you. But for most folks, I would say it's not a good choice to change to pass-fail because of the it's not going to help you that much, and it might in the future kind of hurt you if you just have a pass grade rather than say a B. If it just says P instead of B, that's probably not the best. Probably won't be exactly equivalent to one another. So I understand if you feel like you might want to, but I don't think it's probably a great choice for a lot of students in this class. I would just stick with your standard grading. Are there any questions? I see we've had some folks rejoin the stream. Again, my apologies for any internet hiccups. We do have, in the local area here, there appears to be some internet problems. So my apologies for that. Do you have any questions for me from the chat about getting ready for the exam, which is going to open up on Wednesday for us? So, let's see. Let me look a little bit at the lecture notes from yesterday on the review and stuff like that to see if we can right. So so just the main features of what we're looking at is we're looking at the definition of work, the work energy theorem. These are what I would regard as the highlights, stuff that you probably ought to know about. Definition of work, the work energy theorem, where the total work done is equal to the change in kinetic energy. The definition of the kinetic energy, the two types of potential energy. There's gravitational and then there's elastic potential energy. The idea of conservation of energy, where the total energy in a system, total mechanical energy in a system is the sum of the kinetic and the potential energies. This is one of those things where where if the sum has to stay the same, the kinetic energy goes up, the potential energy goes down, and vice versa. Then we talked about the idea of temperature and heat, and how you heat up objects to change their temperature. Depends on the specific heat and how much matter there is in it. And then we also talked about states of matter, and we talked about what we call the first law of thermodynamics, which is that the change in the internal energy. That's, this U here is not quite the same, but that's what they use. The change in the internal energy, this is the internal energy of a system, is equal to whatever heat is added to the system minus how much work is done by the system. Okay? So that's the first law of thermodynamics. And then the internal energy of the system depends on its temperature and its state. So just to give you a little bit of a conceptual thought on that. Are there any questions on this that I can answer before we call it? I know it's been a little bit of a whirlwind here, a little bit of a, in fits and starts, but hopefully this has been at least somewhat useful to folks, and I do want to make sure that you get your questions answered. Are folks back in the chat? I'm just curious if it says I've got a number of viewers in the chat, but if you could, give me a wave or something like that, that would be good to know, so that I know that folks are actually still watching. And pop some questions in the chat if you've got them. Okay, I'm not seeing anything in the chat. And I don't know if that is because the chat has been desynced or not. hard to say. Okay. Well, I guess because a little bit of problems here, hopefully, I'm going to say this. If you still have questions and stuff like that, use the discussion board. Let's use the live stream discussion boards, the discussion boards that are listed under the live stream. If you have still have questions that did not get answered today on the live stream, which I apologize that there were hiccups with the internet here on my end, please go ahead and post those questions there, and I will answer them by the end of this afternoon for sure. So I'll check in later on this morning and all that sort of stuff. Let me just check in now to see if folks have posted anything in the discussion boards about the chat, about live stream and stuff like that. I don't see anything there. So I think I'm going to end it here, unfortunately, a little bit quicker than I wanted to. Hopefully you have found it useful. I'll tell you what, I'm going to end the stream and then pop it right back up and see if that refreshes the chat for me and see if there are folks that answer. So I'm going to end and pop it right back just for a couple minutes here to see if folks have rated. So let me end the stream and then I'll pop it right back up to see.